Hey everyone, today I have an exciting device with me, the smallest ESP32 dev board with an onboard camera, presenting the all-new XIAO ESP32S3 Sense by Seed Studio. And inside the box we get two additional accessories with it. OV2640 camera sensor module that has a built-in microphone with SD card support and an antenna. You can get this exact board for $14, whereas its basic version does not support the camera module and is priced at $8. Now looking at the hardware, at the center of this board is the main ESP32S3 chip, USB-C port for programming and power supply, B2B connector for the camera module, antenna connector, two push buttons, reset and boot just like every other ESP32 board. On the left side of the board is the power LED and on the right is the programmable or user LED. There are a total of 14 pins on this board, out of which 11 are GPIOs. You can find the pin names at the back of the board. Here is the pinout in case you want to look at it. Now let's look at the specifications of this device. It has a 32-bit 12-core processor running at up to 240 MHz, 8 MB of external PS RAM, 8 MB of flash with built-in Wi-Fi and Bluetooth. This board has a very small form factor, 2 cm in length and 1.75 cm wide. You can see how small it is compared to the original ESP32 board. As you can see, it did not come with header pins, so you have to purchase those separately and solder them onto the board. Since all XIAO boards from Seed Studio are breadboard friendly, this makes circuit prototyping a lot easier. Alright, now that we have our board ready, let's set up the Arduino IDE for programming it. First of all, make sure you have the latest version of Arduino installed on your system. Then follow these steps. Go to File, Preferences and paste this link inside the Additional Boards Manager URL section. You can find this link under the description of this video. Next, go to the Board Manager section and search ESP32. Install the latest version of the package. Once done, connect the XIAO board to your system using a USB-C cable. Then go to the Tools section, Boards, ESP32 and look for the XIAO ESP32S3. Select it and the COM port to which ESP32 is connected. By now, if you see the power LED suddenly glowing less bright, don't worry. It automatically turns off after 30 seconds to save power. Now let's upload this simple blink sketch to see how the board behaves. Please note that the user LED is connected to pin 21 internally, which is unavailable on the header. And as you can see, in my case the LED is blinking perfectly. Now let's put this XIAO board to some use by streaming a live video on a web server. Start by connecting the antenna to the board, as ESP32 does not connect to Wi-Fi without the antenna. I uploaded a simple Wi-Fi server sketch and placed it very close to the router. Even then it didn't connect. So make sure you have that antenna connected. Next, connect the camera module. Then in Arduino IDE, go to Files, Examples, ESP32, Camera and open the Camera Web Server sketch. Now you need to make a couple of changes in this sketch. First, select the camera by uncommenting the defined macro, Camera Models XIAO ESP32. Then type the credentials of your Wi-Fi that you want to connect to. This example sketch requires a lot of memory, so we have to use the external PS RAM available. And to enable PS RAM, first go to Tools and then look for the PS RAM option. Then select OPI PS RAM. And that's it. Now hit the upload button and wait for it to finish. On my first try, the board ran into an error. The program was not uploading and I don't remember the exact error. But I tried several solutions. Pressed both buttons several times, removed the camera, uploaded different programs with no success. So after searching for a while, I got the fix. Before connecting the cable to the board, press the boot button and release it only when the board is connected to your laptop. This will resolve most of your uploading errors. After uploading the program, open your serial monitor. Copy the printed IP address and paste it on your browser. As you can see, ESP32 has successfully delivered the camera server page. Now let's start the stream. The camera is working fine, but with the increase in resolution, the frame rate is decreasing. I think it gives the best result in the HVGA mode. You can play with other settings as well, such as quality, brightness and effects. But as far as the face recognition feature is concerned, whenever I tried to use it, the screen froze. But maybe you can figure this out and let me know in the comment section. One important thing I observed is that the board heats up quickly and reaches a very high temperature. I can't imagine it inside an enclosure streaming video without a proper cooling system. That's why capturing photos and videos and saving them on an SD card is a good alternative. You can find the example sketches here. The camera module supports SD cards up to 32 GB, but to use it, format it to the FAT32 file system first. Then insert the SD card into the camera module and upload the example sketch. There's no use of the antenna in this project, so you can remove it if you want. The quality of the images and video is not that good, but considering the price and size of this thing, it gets the job done. The maximum resolution you can capture is 1600 by 1200. Now let's record some audio using this tiny microphone and save it on the SD card. This is the example sketch for it. Make sure PSRAM is enabled. Now this program starts recording once the serial monitor is turned on, records the audio for 20 seconds and then saves it on the SD card. We can change the time from here, but the maximum is 240 seconds or 4 minutes. We can change the file name as well. Let's upload the program and open the serial monitor. So it's recording the audio now. It will do so for 20 seconds and then the program will stop. I'm sure the audio quality will be good. Once done, open the files of SD card on your laptop. This is the audio I just recorded. Let's hear it. So it's recording the audio now. It will do so for 20 seconds and then the program will stop. I'm sure the audio quality will be good. Not bad. In case you want to power this board using a standalone lithium battery, you can connect its terminals here. And guess what? You don't have to charge it separately. Just connect the USB-C cable and it will start charging your battery automatically. There's a built-in charging circuit that takes care of this. How cool is that? So guys, that was it. I hope you liked this video. You can find all the relevant links in the description. And if you have any questions or suggestions, please leave a comment.